All right, good morning. It is Thursday. It's our last lesson of the week because you guys have Fridays off, or, and I'll kind of explain that for those of you who are new to remote learning. So it's the 29th, Thursday. Make sure you have out notebooks, pencils, calculators. We're going to do this do now together. This is kind of like a review of what we've been doing today. We're going to just, nothing new per se. We're just going to kind of work more on these applications. Next week, we're going to be working on the skills themselves. In reality, like if I could do it over, I would kind of focus on introducing just the skill and then introducing the applications. But again, I'm new at teaching this topic. So just bear with me and let me know if you guys have any questions along the way. All right, so cycling, the equation y equals 9x. So I'm going to go ahead and highlight that for us so we know. So I'm going to highlight, so y equals 1/9 x represents the distance y in kilometers that Patrick traveled in x minutes when training for the cycling portion of a triathlon. The table, so we're looking at the table for the distance Jennifer traveled. So we're comparing Patrick and Jennifer together. So we already have, remember we talked about how equations, graphs, and tables are all related. We can relate all of them. We can represent an equation as a graph or a table. We can represent a table as a graph or an equation, and so on and so forth. So we actually already, for Patrick, we already have his equation. So, all right, P for Patrick. Patrick's equation is y equals 1/9 x. And that means we could, so 1/9 is his constant of proportionality. So that is the rate in which he is training, or the rate at which he is going. Okay, so to find out the equation for Jennifer, we need to find out the constant of proportionality from the table. So if you guys remember, constant of proportionality, K equals Y divided by X. So we need to go ahead and look at one of these points on Jennifer's graph or table, excuse me. Let me get my calculator. So all we're gonna do is we're gonna find her constant of proportionality by taking Y, which if you guys remember, X is on top, Y is on the bottom. So we're gonna take Y divided by X. So we're gonna take this 5, we're gonna take 5 divided by 40. So Y divided by X. So my calculator, 5 divided by 40 is gonna give me 0.125. So, so for Jennifer, her constant of proportionality, so again, I have not a lot of space. I'm trying to relate all of these ideas to one another. If you guys remember, we can rewrite the constant of proportionality formula. So this formula right here, we can rewrite it like y equals kx, which is the format that Patrick's is written in. So we're going to write Jennifer's formula in the same, or her equation in this, using the same setup. So we're going to take, we found Jennifer's constant of proportionality, which was 5 divided by 40, which gave us 0.125. So I'm going to write it using this formula style down here. So I'm going to do y equals 0.125x. So all I did was I took her constant of proportionality, which was the 5 divided by 40, which gave me the 0.125. And I plugged, that was for K, so that's what we got for K. I plugged K in to this formula setup, and so I wrote an equation for Jennifer. So Jennifer is y equals 0.125x, and this means this is her rate at which she's going. So this means in 1 minute, she goes 0.125 kilometers. That's what that means. Okay, so now the last thing says, who has the faster training rate? Well, it's kind of hard to compare a fraction and a decimal. So I'm going to take 1/9. So I'm going to take 1 divided by 9. So if you ever want to convert a fraction to a decimal, you just have to take numerator divided by denominator. Because remember that this bar right here represents division. So I'm going to take 1 divided by 9, and that gives me, so the new formula for Patrick. So I'm just going to draw an arrow. So Patrick's new formula, and it's the exact same formula. I'm just writing it with a decimal. So y equals 0.11x. So in the chat, so we're comparing these right here. We're comparing these two formulas. We're comparing Jennifer and Patrick. I want you to type in the chat, who you think is going faster, Jennifer or Patrick. So we're comparing 0.125 as a pace and 0.11. So go ahead and take a few minutes. I'm going to pull up the chat. So everybody needs to type in who, and if you're wrong, it's okay. I just want you guys to tell me, do you think Jennifer's going faster or do you think Patrick's going faster? Because it's been hard for me because I'm not getting a lot of communication from you guys. So I want to make sure that you are still engaging with me, asking questions. So I want you to tell me who you think is going faster. And we're comparing these two that I circled or that I boxed in blue. So we're comparing the decimal 0.125 to 0.11. All right, so Namaya says Jennifer. Anybody else think anything? Comparing decimals is kind of tricky, but good. Jennifer is going faster. So thank you guys for participating. I do give out PBIS points, by the way. So those of you who are not familiar or are new to Princeton or haven't been getting them because of remote work, I do give out PBIS points. So these are points that you can use. I can show you guys how to log in later or some other time, but you can buy stuff from the store. So you can use your points that you earn to get things like Amazon gift cards or candy or different kinds of cool things that the store provides. So I do offer PBIS points for participation. So I thank you to those who are participating. All right. Any questions about this? This is a lot. We're going to be doing review all today. So we're going to kind of be relating all of these ideas that we've been discovering and talking about. All right. The table and the graph represent the rate in which two machines are bottling milk in gallons per second. So machine 1 is over here on the left. So we've got machine 1 and machine 2. So we're comparing a table with a graph to determine the slope and unit rate of each machine. So if you guys remember, we need to figure out the slope from a table. We can use the constant of proportionality, or we can take that y divided by x, that rise divided by run. So I'm going to go ahead and take this right here. So 0.6. So we've got x and we've got y. Well, that looks like an x. Sorry, guys. Y. Remember, our constant of proportionality formula is y divided by x. So all I'm going to do is take this y value, 0.6. So remember, I'm doing y divided by x divided by 1. 0.6 divided by 1 just gives me 0.6. So and I'm glad that we have two lines. So I'm going to write, machine 1 on that top line since we've got two lines. So machine number 1, we've the unit rate. So this actually already gave us our unit rate, which is nice. If you guys remember what a unit rate is, it's something per 1. So this is saying that 0.6, so machine 1 does 0.6 of a gallon in 1 second. So the unit rate for machine 1 is 0.6 per 1 second. All right, we're gonna look over here at the graph. So we wanna pick a point where it intersects the y and the x axis. So we wanna look at this graph and say, all right, I see that point right there. I'm just gonna pick that one because it looks nice and it intersects with the y and x axis. So this is like the graphs that we saw yesterday. So where they're jumping by 2. So this point right here is actually 8. So, so for this point that I'm talking about, so this point that's intersecting, and I know it stinks because I don't have a lot of places to write stuff. I'll write it up here. So x is going to be 8 and y is going to be 2, 4, 6, because 6. So we've got point, and that's our x and that's our y. So remember, if we want to figure out unit rate or our constant of proportionality, we're going to take y divided by x. So what we're going to do is we're going to take our y, I'll use a different color. We're going to take y So 6 divided by X, which is going to be 8. So 6 divided by 8. So for machine number 2, we're going to find our unit rate or our constant of proportionality, because we have had discussions previously about how a unit rate and a constant of proportionality are the same thing. And guys, remember, I know the term constant of proportionality sounds like a complex math term. All it means is the ratio between numbers stays the same. So is it a proportional relationship? Yes, then it's moving at the steady pace, rate, or ratio. So 6 divided by 8 is going to give me 3/4 or 0.75. So I'll just write 0.75 because that's our unit rate. So this is saying that, and remember, it's Y over X. So this is saying that machine 2 produces 0.75 gallons per 1 second. Okay. All right. So now we want to find the slope and the unit rate of each machine. We found the unit rate. Slope, if we remember, and we'll talk about this part a little bit more next week. We talked about rise over run. So I think it paints a good visual using the graph. So I'm going to go to machine 2 so I can explain it. So we're talking about rise over run. So Y over X, we talked about that. So the rise is going to be 1, 2, 3. The run is going to be 1, 2, 3, 4. So that's going to be our slope. All slope is rise over run. It's the steepness of that line. So if you guys noticed for machine 2, so our rise and our run is, so our rise over run is 3/4. Well, that's the same thing as 6/8. That's the same thing as 0.75. So our unit rate and our slope are the exact same. So for number 1, we can actually just write our slope is 0.6 over 1. That's it. That's all we have to write. So unit rates and slope have a strong relationship, meaning that they're like the same thing. So make sure that we're starting to make those connections. So determine which machine is working at a faster rate. So 6/10 versus 75/100. 75/100 is working faster because that is a bigger decimal. So this is saying that machine 1 is producing 6/10 of a gallon in 1 second. Machine 2 produces 75/100 of a gallon in 1 second. So this is machine 2. All right. All right, this one actually, this is something that you might see in high school or on the air test. So I kind of wanted to break down some questions that you could see in the future using what we've learned this week. So Presert earns $9 an hour. So I'm going to highlight that because that seems important. So $9 an hour. Which table represents this proportional relationship? So $9 in 1 hour. So if you guys are thinking about what we've talked about so far, a unit rate is per 1. So he earns money at a rate of 9 in 1 hour. So K, oh gosh, sorry, I forgot I had my my highlighter still on. So K equals Y over X. Well, in this case, we've got $9, and if you're looking at each of these graphs, I'm going to label X and Y on all of them. Or I keep calling them graphs, tables. So $9 an hour, so $9 per 1 hour. So that is our constant of proportionality for Presert and what he earns in an hour. So we want to figure out which of these tables represents that. All we have to do is look at one of these points and see, does that match our constant of proportionality? So we're going to take 36 and all I'm doing is I'm finding the constant of proportionality for each of these tables. So I'm going to take Y divided by X. So in this first one, I'm taking 36 divided by 4, which gives me 9. So that gives me 9, which is meaning that in 1 hour, they earn $9, which matches what Presert earns. So that's looking like a good choice. However, I'm noticing for table 2, it's also that case. So we can't just make that snap decision. So we need to figure out the second point on this. So I'm gonna look at this right here. So 54 divided by 6 should also give us 9 if it's a proportional relationship, and it does. So 54 divided by 6 also gives me 1/9. And when I say 1/9, I know it looks like I flipped the constant of proportionality. I'm just writing it as x/y to fit the graph. So then for this one, 45 divided by 6 should give us 9 if it's a proportional relationship. And it gives me 7.5. So B is no longer an answer because it's not giving me a proportional relationship. Okay. 72 divided by 8, that should also give me 9 if it is a proportional relationship, and it is. So 72 divided by 8 gives me 9/1. And I know I'm writing it like 1/9. The reason I'm doing that is to keep it, to make sure we know that all of these are equivalent to the things that are on the table. All right, so we already found out that B is not an answer. I want to just rule out my C and my D answers. So 9 divided by 2. So I'm looking at this one right here. That one I can already tell I should get 9, but I'm going to take 9 divided by 2. That gives me 4.5, so that's already not an answer. B, I'm going to take 18 divided by 2. And remember, I'm doing this so I can determine if it's a proportional relationship and if it matches our situation up top. So I'm going to do 18 divided by 2, and that's going to give me 9. So that part checks out. I'll write my check down here. 27 divided by 3. So this is this next part. So this should give me 9. 27 divided by 3 gives me 9. So that checks out. And finally, to see if it's a proportional relationship, 54 divided by 4, if this is a proportional relationship, should give me 9. But I'm going to do 54 divided by 4, and that gives me 13.5. So these two are, the first two points are proportional, but this one is not, meaning that cancels out D. So A is our answer for this one, and this is saying that all of these points are proportional to one another, and they all represent earning $9 an hour as our constant of proportionality. Okay, so I'm gonna go ahead and go on to the next one. Make sure in the chat, if you have any questions, make sure that you are unmuting yourself or typing or something, because I wanna make sure that we're all good. All right, a factory produces widgets. So if you don't know what a widget is, it's just kind of like a, I don't know how to explain it. Like a piece of like metal kind of. So a factory is producing these pieces of metal to work with, like with tools and stuff. So a factory produces widgets at a constant rate. After 4 hours, 3,120 widgets have been produced. At what rate are the widgets being produced? So if you notice down here, all of these answers say per hour. So they want us to find a unit rate. Anytime you see that word per 1 or per 1 hour, per 1 something, they're trying to figure out the unit rate. So all we need to do, so we can take the total amount of widgets, so 3,120, and we can divide it by 4. And the reason we're doing that is we want to figure out how many widgets, so widgets per hour. So we're going to take widgets divided by hours to figure out which one of these matches. So I'm going to take 3,120 divided by 4, and that gives me 780. So 780 widgets in 1 hour. So that means that C is our correct answer for that one. Nice, Nicolasa, good. All right, so what is the slope of the line below? So we can do a few things here. We haven't actually talked about slope, how to identify slope types. We're going to do that next week a little bit more, but I'll give you just like a sneak peek. If a line is going downward like this, so from the left side it's coming down, it's automatically a negative slope. So I know we haven't gone over that, but you might have gone over that last year with like Mr. Green or one of your other math teachers. But slope is going down, so this is negative. So that means both of these positive answers we can cancel out, okay? So we're gonna take rise over run. So I'm gonna pick up, so I've got 2 points I can look at. They've already identified them for me. I've got this one over here and this one over here. So I'm gonna go ahead and, so rise is gonna be vertical, my y-axis. So I'm gonna go down 1, 2, 3. So 3, that's down 3, so that's gonna be a -3. And then I'm gonna go over 1, 2, 3, 4, 5, 6. So -3/6. We can simplify that. You can take -3 divided by 6, and you can get -1/2. So -1/2. So our slope is -1/2. And all I did was I took the rise divided by the run. And since that rise, that vertical axis, that y-axis is going down, I made it a negative. And we're going to work on this a lot more next week. I already kind of have been starting to plan on what we're going to do, and hopefully it's going to click for everybody. I know I've gotten different feedback from people, but I just want to make sure that we're all getting good practice in and everything as well. All right. Jim earns $41.25, so $41.25 in 5 hours. Susan earns $30 in 4 hours. Pierre's hourly rate is less than Jim's, but more than Susan's. What is his hourly rate? So sounds like a lot's going on, but we're comparing Jim to Susan, and we're gonna try and figure out where Pierre's hourly rate falls. So it's less than Jim's, but more than Susan's. So we need to figure out what Jim earns. We need to figure out what Susan earns to determine what Pierre earns. So I'm gonna write, let's see, I'm gonna write J. So Jim earns $41.25 in 5 hours. Susan earns $30 in 4 hours. Again, this is us finding the unit rate. So we want to figure out how much each of them earns in 1 hour. So we're going to take 41.25 divided by 5. So I just took the top number divided by the bottom number so I could figure out what the unit rate is. So at this rate, he is making $8.25 in 1 hour. And then we're going to take Susan. 30 divided by 4 is going to give me 7.5. So $7.5 for 1 hour. So given that information in the chat, guys, I want you guys to put A, B, or C, or D, which one. If Pierre's hourly rate is less than Jim's, so it's less than $8.25, but more than Susan's, more than 7.5. So how much? So type A, B, C, or D. I'll pull up the chat so I can see. Nice. Good, guys. We're looking for an answer that is more than 750. So that's going to be not this one. Oh, sorry. Not this one. Not this one. And then we want to look for something that's less than what Jim earns. Well, Jim earns $8.25, so that cancels out this. So our answer is B. Very good. All right, and I know today is kind of going all over the place. I just kind of wanted to review the skills that we've learned how to do and how to apply them in different situations. So Joelle can read 3 pages in 4 minutes, 4.5 pages in 6 minutes, and 6 pages in 8 minutes. Make a table of the data. So if you wanted to write something like this on your own papers, you could make a table. So you could write minutes over pages, or you could just, if you have lined paper, you could write minutes and then make 3 little cells and then write pages in the next line. So make a table of the data. All right, well, we know that in 4 minutes, she reads 3 pages. In 6 minutes, she reads 4.5 pages. And in 8 minutes, she reads 6 pages. All right, so use the values in the table to find the unit rate. So remember, K is a unit rate. So K equals Y over X. That is how you find a unit rate. You take Y and you divide it by X every single time. So when we want to find a unit rate, we're going to take Y divided by X. So we're going to take, in this case, we can pick any of these points. I'm going to take 3 divided by 4, which in this case is just going to be 3/4. Nice, or 0.75. Good. So we've got, so 0.75 or 3/4. And what, and I actually like, I'm sorry, I hope I'm not pronouncing it wrong, Jimir. I really like your answer because 0.75, that represents, remember, we're still doing Y over X. So 0.75 over 1 represents how many pages they read in 1 minute. So this means she can read 3/4 of 1 page in 1 minute. So I think that's a little bit easier for us to understand than 3/4. So I like the 0.75. Good. All right. Graph the relationship between minutes and pages read. So it's hard for you guys right now because you guys don't have graphing paper, or it's also hard for me to graph on the screen. Next week, we're going to have more practice. So it is really important next week, guys, if you can get some graphing paper or print off that sheet from Google Classroom. And I'll show you where that is in a second. Graph the relationship between the minutes and pages read. So they want us to graph 3. So for every 3 minutes, let's see, every 4 minutes, so I'm going to go to minutes, every 4 minutes, there are 3 pages read. So for every 6 minutes, there's 4.5 pages read. So that's going to be kind of our line, and then that's what our graph would look like. I know it's kind of hard to practice graphing remotely. I'm going to see if I can kind of find something where we can graph together, kind of like an online tool that I can use. So 1 second, I'm going to stop sharing. So thinking about next week, guys, what we're going to be doing is we're going to be focusing on how to find slope from points, slope from a graph, and slope from an equation. And it sounds like, okay, this is what we've been doing, but I want to kind of hammer it in. We're going to do a lot of drill and practice just because this is an important skill for high school. You will see it. So I want to make sure that you guys are all good for that. I want to show you, oh wait, I'm not screen sharing. 1 second. Share. All right. Let's see, my first class played at Kahoot today. So we're gonna go to, I'm gonna move myself over. I'm gonna go to Google Classroom. Oh wait, I already have your Google Classroom up. Here we go. All right, remote math. So again, this week, your only 2 assignments, you need to do slope practice, which is completion. So all you have to do is, do your best. It's for you to practice. So it's for you to see things and practice. And then do quiz 3. You guys can take these as many times as you want. So I know some of you guys weren't satisfied with your grades last quarter. So if you're not getting a good grade on your quiz, you can retake it. And then down here at the bottom, graphing worksheet. This is just a worksheet full of graphs. So if you wanted to print this off at home, you can. Or you can get some graph paper at Kroger or any store. It's not too expensive. I can put some down in the student center at school. So if your parents want to come pick it up, they can. So I will give that down to the 8th grade secretary as well. So if you guys want to come pick that up, feel free. Let's see. I can't think if I have any more things to say. Oh, tomorrow, you do not have class on Fridays. What that is a help session. So if you are feeling lost or want help or want to go over a missed test question or quiz question, or you just miss my face. I'm just kidding. But if you need something, I will be available all day on Fridays. Not all day during our time. So you'll just click that Zoom link that you normally click, and you'll join in and you'll ask me questions. But if you don't have any questions and you're feeling like good about everything, then we do not have class tomorrow. I will see you on Monday. So does anybody have any questions for me? All right. I appreciate your guys' participation today. I will be sure to give out some PBIS points. You guys were awesome today. I will see you all either tomorrow if you want a help session or on Monday. Have a good weekend, guys. Bye.